we're going to do question 1. In 1.1 we are asked to solve for x. So 1.1.1 we're going to solve for x for this problem here. So we have x squared plus 5x minus 6 being equals to 0. So the first step we're going to do is factorize this problem here, equate to 0. The factors of x squared is x and x. Factors of 6 such that they give us the middle term, it's going to be 6 and 1, right? And 6 will take the sign of the middle term, so it's going to be plus, and this would be in negative. So it's going to be x minus 1 being equals to 0, or x plus 6 being equals to 0. Then x equals to 1, or x being equals to minus 6. So these are our solutions of x. We're going to do 1.1.2, where we are given this problem here and we are asked to write our answers to 2 decimal places rather. So we're having 4x squared plus 3x minus 5 being equals to 0, and the quadratic formula is equals to minus b plus or minus root of b squared minus 4ac divided by 2a, and our value of a is equals to 4, our value of b being equals to 3, value of c is equals to minus 5. So we're going to substitute these values into our quadratic formula. So it's going to be minus into 3 plus or minus the root of 3 squared minus 4, our a value being 4, our c value being minus 5. And then we divide by 2 into our a value being 4. So the solutions of x that you're supposed to get for this problem is minus 1.55, or x is equals to 0.80. So these are your solutions of x in 2 decimal places. 1.1.3, where we are also solve for x for this inequality problem. So the first step, we're going to write our equation 4x squared minus 1 being less than 0, right? And we're going to factorize this problem here. So we're going to have 2x and 2x, right? Difference of 2 squared, so it's going to be plus 1 and minus 1 here. Then our critical values is 2x plus 1 equals to 0, or 2x minus 1 equals to 0. So we're going to have 2x being equals to minus 1, or 2x being equals to 1. So we divide by 2 both sides. We have x being equals to minus 1 over 2, or x being equals to 1 over 2. So these are our critical values, right? And remember that the solution that we want is when our y value is negative, right? Because the inequality is less than 0. So we want to go to our number line, right, and present our critical values. So we have a critical value of minus 1 over 2 and a critical value of 1 over 2, right? So these are our critical values. So we're going to test values before and after our critical value. So a number before minus half it can be minus 1. A number between minus half and half, it can be 1 over 4. A number after half, it can be 1 also. So you're just going to test these values here and identify the signs of y, right? Because you're going to be testing them into the equation of 4x squared minus 1, right? So where you see x, you would put x being equals to minus 1, and then find its solution, right? And then you also test this one here, where x is equals to 1 over 4, and find the solution for that. So find the sign, and then when x is equals to 1, you find the solution, right? So what I found was when I substituted x being equals to minus 1, I got a positive solution of y, right? So meaning that here it's going to be positive solution of y. So whatever x value that is less than 1 over 2 minus 1 over 2 is going to give you a positive solution of y. And then when I substituted for x being equals to 1 over 4, I got a negative solution of y, right? So and then after half, which is this critical value, I got a positive solution of y. So we're only interested in the negative solution of y, which is this one here. So you will conclude using your critical values. You will say x must lie between minus 1 over 2 and 1 over 2. So this is your solution for this problem here. Now we're going to do 1.1.4. So we're having the root and another root inside where it's 32 plus x, and then there's brackets. We have another root here which has a root of 32 minus x, and then there's a close bracket being equals to x, right? So to solve this problem, we can use a difference of two squares, right? You know, when x squared minus 1 is the same as x, let me remove this, same as x plus 1, x minus 1, right? So you're just going to do the same thing inside here, and we'll use one bracket. So it's just going to be this big bracket here and a difference of two squares inside. So it's just going to be the root of 32 plus x and the root of 32 minus x, and then equals to x, right? So we're just going to square both sides, so we can square this side here and square this side here, and then we'll remain with the root of 32 plus x, the root of 32 minus x being equals to x squared, right? So since I said this is the difference of two squares, can simply multiply this square root and this square root here. You're gonna have 32 and then minus, we don't have to multiply this root of 32 and this minus x, right? Because the difference of two squares, you can simply multiply this x and this x here. We'll have minus x squared like this, right? So it's going to be equals to x squared, and then we transpose this to the other side. We have 32 being equals to x squared plus x squared. So we have 32 equals to 2x squared, right? And then we divide by 2 both sides. We have x squared is equals to 16, and then the square roots both sides, we have x being equals to plus or minus 4, right? And then our final solution would be equals to 4. So that is the solution for this problem here. Now we're going to do 1.2, where we are asked to solve for x and y for these two equations here. So we're having y plus x being equals to 12, and we can say this is our equation 1, and xy is equals to 14 minus 3x being equation 2, right? So let's choose one equation so that we can use as equation 3. Let's choose this one because it looks simpler. We can simply say y is equals to 12 minus x, and it's equation 3. So we're going to substitute equation 3 into equation 2, right? So whenever we see y, we're just going to put 12 minus x. So we're having x into our y, right? So it's just going to write 12 minus x being equals to 14 minus 3x, right? So this x will multiply everything inside, so it's going to be 12x minus x squared is equals to 14 minus 3x, right? And then we're going to collect like terms, so it's going to be minus x squared plus 12x plus 3x minus 14 equals to 0. And then minus x squared plus 15x minus 14 equals to 0. Divide by negative all sides. And then we will have x squared minus 15x plus 14 being equals to 0. Right? So we're going to factorize this problem here. So it's going to be x, and then factors of 14 such that they give us the middle term. It's 14 and 1 have to be negative both sides, and then we equate to 0. So x minus 1 is equals to 0, or x minus 14 equals to 0. X is equals to 1, or x is equals to 14. So these are your solutions of x. Now let's find solutions of y. Remember that y is our third equation, which is equals to 12 minus x, right? So when x is equals to 1, our y value is equals to 12 minus 1, which is equals to 11, right? So when x is equals to 14, our y is equals to 12 minus 14, which is equals to minus 2. So these are our solutions of x and y. Now we're going to do 1.3, where we are told to consider the product of 1 times 2 times 3 times 4 all the way up to times 30. And we are asked to determine the largest value of k such that the factor is 3 to the power of k, right? So what we know is this, that we have in a product of 1 times 2 times 3 times 4 all the way up to times 30, right? And the factor that you are given is 3 to the power of k, right? So this is a hint. It tells us that because we want the value of k, which is on top, right, it's an exponent. It means now that this 3 to the power of k must be equals to the same base of 3, such that we will just drop the exponents, right? So let's find the multiples of 3 that exist in this product here, right? So we're having 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, right? So I'm just going to write them properly. So it's going to be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So these are our multiples of 3, right? And then let's write these multiples in terms of base 3, because our factor is 3 to the power of k. So this 3, to write it in exponent form, you can simply say just 3 to the power of 1. And this one here, we know it's made of 3 times 2, right? So just going to write the 3 that exists there. And then this one is made up of 3 to the power of 2. And then here we can say 4 times 3, right? So which is actually 3. And then 15, we know it's 5 times 3. So you can just put 3 here, so all to the power of 1. And then here we can say 3 to the power of 2 multiplied by 2, because 3 to the power of 2 is 9. 9 times 2 is 18, so it's going to be 3 to the power of 2. And then here it's going to be 3, because 7 times 3 is 21. And then here we have 24, so it's going to be 3, because 8 times 3 is 24. And then this one here of 27 is 3 to the power of 3. This one here is 3 to the power of 1, right? So we're having all these bases here, but we need to add all the exponents of these bases because we already have the factor. Our factor is 3 to the power of k, right? And we just need to equate it to 3. We have exponent of 1 here, exponent of 1, exponent of 2, exponent of 1, exponent of 1, and exponent of 2, exponent of 1, exponent of 1, exponent of 3, and exponent of 1. So we'll simply add the exponents. So it's going to be 1 plus 1 plus 2 plus 1 plus 1 plus 2 plus 1 plus 1 plus 3 plus 1, right? So by adding the exponents, we have 3 to the power of k being equals to 3 to the power of 14. So this concludes now that the largest or maximum value of k is equals to 14 for this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.